Most interesting thing in tech, a new paper that just came out earlier this week from researchers at Microsoft, University of Pennsylvania, it's a preprint, about a concept called experiential reinforcement learning. And it's a way of making AI models smarter or more accurate by modeling the way they get feedback more in the way that we humans respond to it. So normally, the way you train an AI model is it answers a question and it either gets it right based on some external source or it gets it wrong. Or maybe a human gives it a thumbs up or a thumbs down. That feedback is then fed back in. You get millions and millions of data points. Every connection that leads to something right is strengthened. Every connection that leads to something wrong is weakened. It's a relatively blunt way of having models learn, and obviously it works pretty well. But this is slightly different. What it does is it says if it gets something wrong, it then has the model write up an explanation for why it got it wrong. It sort of explains in text. So you ask the model, what is the capital of New York State? And it answers Buffalo, or it answers New York City. Well, that's wrong. The capital is Albany. The model is then forced to write why it got it wrong. Let's say it answered New York City. Oh, I got that wrong because it's the most famous city in New York or the biggest city in New York, and I overemphasized that. So now let me think again. It answers Albany. It gets it right. Then not only does it reinforce the connection between the capital of New York being Albany, but the concept that when choosing a capital of a state, you shouldn't over-index on the largest city. So that way you're not only improving one specific answer, what is the capital of New York, you're improving the whole framework. This isn't a totally new idea, but what's new about the paper is that it's used in the training stage, therefore making the models more efficient, not in the inference stage, where if you added a second loop with a bunch of text, you would slow things down quite a bit and there'd be a lot of compute costs. So it's a pretty smart idea. I also like it because it's a way of remembering that there are ways of making these models better, not just by increasing scale, not just adding more computers, more data, but by teaching them more about the way we learn. I also hope in the future that this process works in reverse, so we can understand better how models learn to improve the way we learn, but that's a topic for another day. All right, that's the most interesting thing in tech. See you tomorrow.